For this leveling up exercise, we'll use the same auto EPA data from 1993 that we've been using just because it's convenient. So I'll double click on that file. I will highlight just the data and not the definitions of the data. I'll click on import and let's move this up. So what we're going to do this time is we're going to look at the influence of the number of cylinders on the max city miles per gallon and highway miles per gallon. So in order to do that, this is right now a continuous variable. Let's look and see what we have there using the distribution platform. Looks like we have a number of values ranging from 3 up to 8 cylinders. So I'll close that out. And I'll just do a little shortcut here. I will click on the red triangle once I've highlighted this. And you can see I can recode right from this menu here. And when I recode, what I'm going to do is I'm going to group together 3 and 4. I'm going to group together 5 and 6. And then I'm going to have 8 as its own group. So I'm going to highlight the entire row for 3. Make sure it's the entire row. Hold the control key and highlight the next row, and now you see that the group is highlighted over here. So I'll click on group, and then I'll edit the value that's left here, and I'll put in 0 LOW for low. I did 0 so that they'll be sorted in low, medium, and high order when I look at these on the graph. So I'll click here, and now Jump asks me, do I really want to convert this to a character column? And I'll say yes. And then I will say 5 and 6 here, and I will group those, and I'll put 1 medium for that. Then for the last one here, I'll say 2 high. So again, this will group them and then order them. I'll click over here. And this last little one here I want to get rid of. I want to make sure that's a blank, so I'll get rid of that period in there. And I'll again click over here. And then finally, I'm going to click on recode, and this will be my new variable up here called number of cylinders. So I'll click on recode, and that should give me a categorical variable that I can use in analysis of variance. To get to analysis of variance, I go to Analyze, I say Fit Y by X. I'm going to put my new categorical variable, number of cylinders, in the X factor, and then let's look at both city and highway. You know, you can do 2 at once. That's because, and actually you could try a whole bunch of categorical variables down here also. So Jump gives you the ability to create many analyses all at once so that you save yourself a lot of time. So I'm going to click on OK at this point. And now I have my city miles per gallon and my highway miles per gallon. And the next thing I can do is I can click on one of these red triangles, but if I hold the control key, remember I get to do both analyses at the same time. So I'm going to click on the control key, and I'm going to say means and the standard deviation. Let's move this up a little bit. And you can see here that for city miles per gallon, we have our low number of cylinders gives us 25.6, our medium gives us 18.4, and our high gives us 17. And then if we look down at city, we've got 25, 25, and 32. The question is, can we really distinguish between these values, a 17 and an 18.4? Is that just a matter of chance in the sample that we have, or is that actually a real difference that we should be able to distinguish? So let's close out the the highway here and focus in on the city. So I'll go back to my red triangle and I will say, give me a means analysis of variance. So that's the main analysis that we'll be doing here. I click on that. It automatically fills in the means diamond. So remember, the width of the mean diamond is telling us how many records we have of that category, and then the 2 lines show us the 95% confidence interval. And generally, looking at where we are with this, looking at where we are here, those are very close to each other. They seem to overlap, and so our prediction is that when we drill down into the post hoc analysis, that is what we do after the initial analysis, we're going to find out that these two are the same. We can't distinguish them. In other words, we have to we cannot reject the null hypothesis that these are the same. but we'll find that this one is actually different. So I'll click on my red triangle and I will say compare means, all pairs Tukey HSD. A reason we're choosing this rather than any of these other ones here is because this one is a little bit more restrictive than the each pair students T's, and it seems to work well in many cases. So we'll click on that one. You'll see that JMP gives a whole lot of output here. One of the most useful things are these circles right here, the concentric circles. And they essentially are showing you which ones of these are the same and which ones are different. So if you have something like this bottom case where the small circle is all the way inside the little big circle, then those two cannot be distinguished. If the circles are not touching each other, like this one and the other two, then they can be distinguished. And so we'll find that the p-values represent exactly what this is showing us. If I actually click on the circle, it'll highlight one or in red that's different. The others will be the same color. Once again, if I go down and I click on these two circles, these two are the same. They're the same color. This one is a different color. So a lot of people find that these circles are quite useful, especially in a case like this where the differences are quite clear. As I scroll down to look at the rest of the output from the Tukey test, you'll see that it gives us something called the HSD threshold matrix. Now that is not causing us any harm here. We don't really need to look at it. We don't need to really look at the confidence quantile. We can just close those out. Sometimes this HSD matrix is very, very wide and it causes the output to scroll all the way over. It's kind of a pain. So clicking that off will then move the window back and make everything else more visible. And the connecting letters report is showing us the same thing that we're seeing in these circles up here. But in this case, it's saying if the letters don't overlap, so A is not listed here with B. If they overlapped, it would say AB, but A is by itself, B is by itself. But here, again, you can see that these two have B. So in essence, if you want to get a very quick and dirty look at what the differences are, you can look at this connecting letters report. If you really want to look at all of the t-tests that are being done, in the order differences report, it will show you which p-values are significant and which are not, and it's showing you each pair that it's testing. But the difference is that when it tests all of these pairs together, it makes adjustments in the p-values to take into account that we're doing multiple tests. Okay, I scrolled up to the top here and I'm going to close out this entire analysis. So you can see I have just the two analyses that I ordered up and both of them are closed. I'll open up the analysis for highway miles per gallon. And now I can use my red triangle once again. I can say means ANOVA. By the way, we did not call attention to this fact right here in the first analysis, and that is the overall analysis of variance. It's saying that we are going to reject the null hypothesis that all three of these means are the same, which tells us that at least one of the means is different from the other two. And so once again, if I go and I ask for the compare means, all pairs Tukey HSD, I see an extremely similar result here, and medium and high would appear to be the same, whereas low would appear to be a higher miles per gallon. And we can confirm that just by looking at these circles, or we can look at the other data. By the way, when you use other statistical packages, you will not get all of these different ways of looking at the results. You'll probably have to go to something like a order difference report down here, look at the p-values. So be prepared that the data would not be presented to you in such a convenient way. I've moved back to the main data table here, and I want to ask one more question before we move to the second example. How many records do we need in order to detect a very small difference in this case? So right now we see that the differences are 25.0, 25.2, and we could not detect that difference. So how many records would we need in order to be able to detect a difference of 0.2? So let's go back to the main data table, and first of all we need to know the standard deviation. Which one are we on right now? We're on highway. So let's go back and say Analyze, Distribution. Let's grab the highway miles per gallon, click on OK, and then we'll see the standard deviation is our famous 5.33. I'll click out of that. Then I'll go to Design of Experiments. I'll say Design Diagnostics, Sample Size and Power. And then now I'm going to do K sample means. Last time in class we did 2 sample means, but here's K. And I'm going to put in my standard deviation of 5.33. And so I wanted to be able to find some difference like 25.0, 25.02, and 25. Let's just make this like it was in the example up there, 32. 10 prospective means. You can basically take the means that you got and use this as a way to check to see if you have enough members, or you can also put in more of a template of what you want, but you should put in the same number as the means that you're actually testing here. And then down here you put in the power, and we use 0.8 as our standard. So we're going to see what the sample size is as soon as we click Continue on this menu. So I'm clicking Continue, and it says that we only need 29 records in order to detect this much of a difference, which means that we are in good shape. I'm going to actually, though, erase that 29, and I'm going to change this to 25.2, I'm sorry, 0.04. So now we really do have a very, very small difference in the means, and let's see how many records we would need. We would need to have 1 million records in order to be able to detect that small a difference. What if we said we wanted to just say it was 0.2 rather than 0.02? 0.2, 0.4, and let's hit Continue. And we need 10,000 records in order to get a difference of 0.2 amongst all of our means. So the bottom line here is that it really is a necessary part of an analysis, especially when you have a small number of records, to check the power and see what is the actual probability. With this small a difference here, you can see, if I take that out and say Continue, I'm going to see the graph here. Let's take that out and also take the power out. Now it's going to show me the graph, and again I can get the crosshair tool here from the magic menu, and then I can go up and down this graph, and you can see that right now, how many records do we have? We have way fewer than 24,000, and that's really where we go off the graph. So it really won't tell us anything below that. So we would need to get at least 2,600 records in order to be able to have a 25% chance of not making a type 2 error. I'm now closing out the data table that we had, so I'll say Close All. I'll say No to saving any changes, and now I'm going to go to the jump file called Air Noise Data Sample Fake. Just to remind you that I created the data with the same general pattern, but it's not data that I got from the company. This is something that you can download off of Brightspace for this exercise. So I'm going to double click on that. And we see that I've given you a substantial number of records, in this case 400,000. If you remember back in class, I actually had 6.6 million records in this file, so I've actually taken a rather small subset, a little bit less than 10% of the overall, and I've cut out some airports so that I have a smaller sample here. So what's the data that we have? We have the airport code and the airport name, and then we have the transaction date for each line, and then we have the quantity for that particular date for that particular airport. So what we want to find out is how do the airports differ from the perspective of the number of average complaints per day. So that's what we're going to be analyzing. So we'll say Analyze, and we will say Fit Y by X. And just as we did before, we're going to take our categorical variable. In this case, we'll use airport code, put that on the X factor, and then we're going to take quantity and put that on the Y factor, and then we're going to click on OK. Now, one of the things I could have done was I could have visualized beforehand, before I do the analysis. The nice thing about JMP, as you are realizing, is that JMP always starts with a visualization as the first thing that we see. So I could use the graphing platform, but I always can see some type of scatter plot or other graphic representation of what's going on when I start the analysis. The problem here is that the scale is very, very wide because there are just a small number of points where there's a massive number of complaints on that day. And so we can't see any means, we can't see any means triangles here. If I go ahead and click on the red arrow here, I can get the means and standard deviation. Should be putting the green means triangles here, and you can just barely see a little bit of green. Even if I expanded this out, I probably wouldn't be able to see anything. But I look down here and you can see that it says, oh, the means are like 3.6, 3.4. That's going to be at the very, very bottom of my scale over here. So I'm going to use a trick. I'm going to go ahead and double click on the y-axis, and instead of having a minimum of -100, which really couldn't be true unless we have bad data, so we should go back and check our data, but I won't take the time to do that. I'll go from 0 and I'll go to 5. So I'm going to cut out showing all of those extraneous points, even though we don't get rid of them as outliers because they are in fact part of the real data that we have, but I don't have to show them on my graph. So I'm going to say 0 to 5, and then I'm going to click on OK. And now I'm going to go ahead and say display options and get my mean diamonds. And now I have a much better idea of what's actually going on with all of the different means for Atlanta, Denver, JFK, Los Angeles, and these other airports, Seattle. So it looks like there may be differences between some, but not necessarily between all of the ones that I have here. And so what am I going to do next? I'm going to go ahead and I'm going to look at the actual means ANOVA analysis, which is right here. And we will see that the overall p-value is less than 0.05. So if p is small, reject is the call. So what is the null hypothesis here that we're rejecting? It is that all of these means cannot be distinguished from each other, that at least one of them is, so the alternative hypothesis is that at least one of these means is different than all the rest of them. And the question is now, since this says that yes, indeed, one can be distinguished or more can be distinguished, which one is it? And I can get a preview of that if I sort these in descending order. So by the way, if I click in a table, this is a table right here, I right click in the table, I get a menu that says sort by columns, and then I can sort by mean, click OK, and I can see that we have a range of Seattle of 1.4 all the way up to TPA, which is 35.6. TPA is Tampa, by the way, which I stopped the tape for a moment and I went and looked up. We have the airport name here, so it's right in the data that we have. Let's find out what the Tukey HSD analysis tells us. That is to say, can we actually distinguish amongst these means, since we did find that overall at least one of the means is different from some of the other means. I'm going to click on the right triangle. I'm going to say compare means, all pairs, Tukey HSD. When I do that, notice I come down here and you'll see that the HSD threshold matrix is open, and that pushes the output way over to the right hand side. If I had even more levels of this variable, it would be even worse, so I can just close that out. So that's not bothering me. Now let's go back up and look at these circles and see what they're telling us. If I click on this circle here for Seattle, you'll see that it is by itself. I click on TPA, which is Tampa. Sorry, that's JFK, and that's also by itself. But you'll say, Professor, these are overlapping. Why doesn't that mean that they're considered the same? It's because these angles at the point where the tangent hits this circle at this point that they intersect here, that angle is so acute that it indicates that the p-value is not going to be less than 0.05, and that's actually covered in the book. Now, it would appear that all three of these are the same, but that's not quite the case. So we have to click each circle individually. Let's start with one of the innermost circles. We'll start with this small one here, and that's LAX, and LAX and MCO cannot be distinguished from each other. Let's get the next biggest one, and I get LAS and MCO. Those cannot be distinguished from each other. If I click the outside circle, though, you'll see this large one, MC, and that can also not be distinguished from both LAS and LAX. So this is showing a very specific pattern of which ones can be distinguished from each other. If I go down and look at the connecting letters report, you'll see that, in fact, for example, Tampa and Atlanta, they do not share a common letter, therefore they can be distinguished. They should be distinguishable given the fact that these numbers are so different, 3.6 versus 35.6. But when we look at LAS, MCO, and LAX, we can see that those numbers are very similar to each other. And so MCO cannot be distinguished from LAS because they share a letter. LAX cannot be distinguished from MCO because they share a letter. But LAS only has C, and LAX only has D, and so they can be distinguished from each other. And that's exactly what we were seeing with these circles up here. So also remember that you might get a statistical package that does not show you the letters report. It may only show you the pairwise p-values, and then you have to sort of piece together for yourself exactly what the differences are. Let's see what it looks like if we only have these three values here. Or in fact, let's do 3 values and see what we get. If I put on a local data filter, and then I'm going to filter on airport code. And by the way, don't forget I can do the red triangle and I can say display options in a checkbox, which I think is a little bit more convenient here. So let's see, which ones do I need? I need MCO, and I need LAS, and LAX. So LAX, LAS, and MCO. So now I've just got those three here, and what happens to my p-value? You can see that because we have so many records, probably, we still have a significant p-value. If I only do a pairwise comparison here, if I just say, let's see, LAX and LAS, then this reverts down to the pooled t-test. So we are actually doing, let's look at the red triangle up here too. We can now do a regular t-test because we're down to 2. If I turn that on, I close out so I've just selected 2 here. I've closed out the pooled t-test for ANOVA, and I'm looking at the regular student t-test that would be the usual that we would use here. And this is telling us that LAX could only be considered different from LAS if we at first made the assumption that LAX should be larger than LAS. That is, or sorry, we're looking at this less than. So we should have made the assumption that LAS is actually bigger than LAX. And since we have no reason for making that assumption, we would fail to reject the null hypothesis. This is too big here. I just did something I don't know how to undo. I figured it out. I just simply had highlighted this table, I grabbed it, I moved that over and made it smaller, and I needed to find it and grab it and move it out to make it bigger. So I was saying that this is the direction of LAS being bigger than LAX, and we would have no reason to do a one-tailed test here anyway, because we had no reason to believe that those would be different only in one direction, and so our p-value here would cause us to fail to reject the null hypothesis. Finally, for the last question on the quiz, go ahead and click on Seattle here, and then there'll be a question about the output. You'll have to actually go back to the red triangle and do the Tukey HSD also in order to answer the question.